Now we need to verify the following. Let us begin. So we'll start our proof from the left hand side, but before that, let's try to recall the formula that we'll be using here. So whenever we have tangent of the compound angle A plus B, then this can be expanded to get tangent of angle A plus tangent of angle B, whole divided by 1 minus tangent of A times tangent of B. And if we do subtraction, that means if we have tangent of A minus B, then we will get tangent of A minus tangent of B divided by, now this time we'll have 1 plus tangent of A times tangent of B. Now let's use these two formulas to expand each of the two terms on the left hand side. So for the first term, we have tangent of pi over 4 plus theta. So here A will correspond to pi over 4 and theta will be B. That means we now have tangent of angle pi over 4 added to tangent of the angle theta divided by 1 minus the product of tangent of pi over 4 times tangent of theta added to, now tangent of pi over 4 minus theta, that will be tangent of pi over 4 minus tangent of theta whole divided by 1 plus tangent of pi over 4 times tangent of theta. This will be equals to, now what's tangent of pi over 4? That has a standard value of 1. So we get 1 added to tangent of theta divided by 1 minus tangent of theta added to 1 minus tangent of theta divided by 1 plus tangent of theta. Now let us combine these two fractions. So here we have a combined denominator 1 minus tangent of theta multiplied to 1 plus tangent of theta. Next what we have, the first term will be 1 plus tangent of theta whole squared added to 1 minus tangent of theta whole squared. So this is going to give us, now what we'll do, we'll expand 1 plus tangent theta whole squared to get 1 plus tangent squared theta plus 2 times tangent of theta added to, so 1 minus tangent theta whole squared will be 1 plus tangent squared theta minus 2 tangent theta whole divided by, now we'll have to take the product of 1 minus tangent theta and 1 plus tangent theta. So this is simply the difference of 2 squared. So we have 1 squared minus tangent squared theta. Now we can cancel out 2 tangent theta and negative 2 tangent theta, leaving us with, so in the numerator we have 2 plus 2 times tangent squared theta, and the denominator we have 1 minus tangent squared theta. What we can do, we can factor out 2 from the numerator, leaving us with 1 plus tangent squared theta divided by 1 minus tangent squared theta. Now we have a standard formula. So whenever we have cosine of the angle 2 theta, that can be expressed as 1 minus tangent squared theta divided by 1 plus tangent squared theta, which means that we can rewrite this entire expression as 2 divided by, so here we'll divide both numerator and the denominator 1 plus tangent squared theta. So that gives us 1 minus tangent squared theta divided by 1 plus tangent squared theta. Now what we can do, we can replace this with cosine of 2 theta. So we get 2 over cosine of 2 theta. Now cosine of 2 theta, that is the reciprocal of the secant function. So when it goes to the numerator, we get 2 times secant of 2 theta. And this is the expression on the right hand side. Hence we have successfully showed that the sum of the two tangent function, tangent of pi over 4 plus theta and tangent of pi over 4 minus theta, that's given by 2 times secant of 2 theta. Hence proved.